Welcome to Trojan Model Hubs, hacking the ML supply chain and defending yourself from threats. My name is Will Armiros. I'm a senior software engineer with Protect AI.
I'm Sam Washko. I'm a software engineer here at Protect AI.
And so today we're going to be going over some of the vulnerabilities of machine learning and their supply chain. So we're going to start by talking about some model serialization attacks and how you can scan your models to both detect and prevent those, and then go into more nuanced supply chain attacks, including data and model weight poisoning attacks, and how you can use AI bills of material to help with those. So with that, Sam, take it away.
All right, so going to start with talking about model serialization attacks. Do y'all know about Hugging Face? Sorry, not that Hugging Face. Talking about the public model hub Hugging Face. So AI is becoming increasingly democratized. It's rarely these big tech giants developing models entirely in-house now. A lot of times we have large foundation models trained on more generalized data developed by one organization, and then AI teams will rely on those, take them down from the public model hubs like Hugging Face, and fine-tune them on their more specific data that's more relevant to their use case. And then that's what often goes into deployment. Sometimes it's multiple rounds of fine-tuning. And this leads to a very open nature community attitude on these public model hubs because everyone's contributing to the same community, iterating on the same models. And this leads often to a nature of implicit trust in these models. And this leaves us vulnerable to model serialization attacks. So when you have a model that you're actively using, it's going to be loaded into memory. But when you need to save it or share it with anyone, it needs to be serialized in order to put it into a file. So serialization is just the process of converting an artifact that's in memory into a character stream. And for machine learning models, this is going to consist of tensors, which are like the big vectors of the weights of each layers, and the model architecture code. And the serialization format needs all of the information that is needed to reconstruct the model. And in many formats that translates to code, which means that an attacker can inject malicious code into this. And that's just going to run automatically when you go to deserialize because the protocol thinks that that's all the information needed to deserialize. And the insidious part of this is that it might not affect the model behavior, like the output or the performance. So you might not even know that this has happened. So in a typical serialization workflow, we start from the model, go to the byte stream, put it up to the artifact store, and then deserialize back into byte stream and model. But in a model serialization attack, that injected code is put into the file either before it hits the artifact store or if the storage is compromised in some way. And when you go to deserialize and execute those instructions, you end up with arbitrary code execution. And this becomes kind of the modern Trojan horse, where we all remember the early internet days with the Trojan horse viruses. It's evolved with the times because this is a way that an attacker can just gain the ability to do arbitrary code execution on your machine. They can steal credentials or sensitive data. They can poison other models. We're going to talk about that a little bit later, or the data sets on your machine. They can open a backdoor that they can use later. And classic antivirus software like ClamAV is not going to catch this because it's in the serialized code. And Pickle is especially vulnerable to this. Pickle is a very common, it's the Python native way of serializing. And a lot of the popular machine learning frameworks end up serializing in Pickle. PyTorch is one of the most popular. And under the hood, it's doing the architecture in Pickle. Pickle's not the only one that's vulnerable. Keras and TensorFlow are also. So this is not just a theoretical problem. We found 3,354 files on Hugging Face currently, just publicly available, that are capable of model serialization attacks. And 41% of these were not flagged by Hugging Face. Hugging Face runs Pickle Scan, which is an open source, very basic model serialization attack detector, but it doesn't catch everything. It doesn't have a complete list of operators or formats. So you can't trust any of these implicitly. So our solution is model scanning. We need a AI-specific scanner to catch these. And we have an open source tool that I've done a lot of work on called Model Scan, and just available through pip or cloning on GitHub. And this detects the malicious operators without needing to deserialize the file and put yourself at risk to the attack. So for Pickle, we go through the opcodes in the Pickle and try to reconstruct what it's putting on the stack and what would it execute on your machine. We're looking through the layers of the architecture. Yeah, so we support all of the major Pickle-derived formats and the other ones that are vulnerable to this. And then we have our commercial product, which is Guardian, that goes a bit deeper, has a few more capabilities, has the ability to have a gateway for sitting in the middle of when you're making a call to Hugging Face. We scan it first and block it from ever downloading if we find anything suspicious. And then we also have the capability of the scanner, where if you have your third-party models or your first-party models that you're developing and having in your own model storage, to take a very zero-trust attitude towards files, you don't know whether your storage could be compromised. A contractor could have different security attitudes than your organization holds. So scanning, even ones that you make first party, is also important. And Guardian has the ability to set policies for that as well. So.
Thanks, Sam. So now we'll talk about another threat, which are ML supply chain attacks that can actually compromise all of the pieces that go into building a machine learning model. So the reason that supply chain vulnerabilities are a concern with machine learning models is that by themselves, these ML model artifacts are total black boxes. So if you just have a model file, you have no way of knowing where that model came from, what code or third-party libraries were used to train that model, and what data sets that model was actually trained on. And this is a big concern because, as we just learned from Sam, model files can have model serialization attacks, and these attacks can actually be injected by compromised dependencies or open source libraries that are vulnerable to inject these model serialization attacks. But also other pieces of the ML supply chain, such as data sets and the models themselves, can be compromised through what are called poisoning attacks. So to talk a little bit more about those poisoning attacks, basically a poisoning attack is a contamination of a data set or a machine learning model in order to alter the desired outputs of the machine learning model. And this can do anything from having the model misclassify certain edge cases into an incorrect and nefarious output, or it can even do more general things such as making a model evade its guardrails that are in place to make sure it stays safe, or having it hand out misinformation or dangerous information. So one example to make things a bit more concrete of data poisoning out in the wild is you can imagine a model that is trained to identify stop signs based off of images. So we can see in this first example on the left that it's a normal stop sign that our model is able to classify as a stop sign. However, if an attacker is able to gain access to this data set that's training the model and can alter less than 1%, so a very, very small amount of the samples in this data set, they can make very small alterations, such as in this case, just adding a sticker or some other small piece of data to the stop sign. which to a human still is clearly a stop sign, but you can trick the model into thinking that, in fact, when this sticker is present, this image is now a yield sign, or even more concerningly, an 80-mile-per-hour speed limit sign. And so you can imagine if this model that's been trained on this poison data set gets deployed into an autonomous vehicle, and it sees a stop sign with a sticker on it, it doesn't think to stop anymore, it thinks to accelerate to 80 miles an hour because it's been trained on poison data. So these types of attacks can have really serious consequences if they are not detected and actually put out into production. So how do we go ahead and take a picture of that one if you want? So how do we go ahead and actually detect these poisoning attacks and other types of supply chain vulnerabilities that might happen for a machine learning model? The answer is AI bills of materials, or AI bombs. So an AI bill of materials is basically an extension of a software bill of materials, or SBOMs. And SBOMs are a pretty industry standard tool for keeping track of all of the ingredients or all of the inputs that go into a software application. And they were actually recently mandated to be produced in all software applications in government organizations by an executive order signed 2 years ago by President Biden. And AI bills of material are an extension of these SBOMs. So in addition to including all of the third-party libraries and other open source packages that might have gone into training a machine learning model, an AI bomb is also going to include a list of data sets and other properties about the machine learning model that help you understand where it came from. So to go a little bit deeper into what would be in an AI bill of materials, you're going to have things such as what type of model is it? Is it a classification model, or is it a large language model? Where is the source of this model? Did you download it from Hugging Face, which we found, again, can have a lot of vulnerabilities? Or did you build it in-house or get it from somewhere else? And then, of course, we need to have the versioned training data that was used to train this model. And so in this case, we want to have all of the different data sets, references to a snapshot of those data sets at training time, and whatever version they were, so that later on we can go back to those data sets if we suspect there was poisoning and see exactly what that data set contained at the time of training. We can also have things like metrics for the model's performance, and then also the foundational model lineage. So if you fine-tune a large language model, for instance, we want to know not only about the fine-tuned model, but also its parent foundational model. Then lastly, you can also have attestations, which are like cryptographic signatures in these bill of materials that can be a way of verifying that this model came from the author who claimed to produce it. So it's all great to talk about AI bill of materials, but they're not very easy to produce. So that is why Radar from Protect AI is offering the ability to automatically generate an AI bill of materials for every single model that your organization produces. So basically, Radar will track all of the data sets, pipelines that train models, as well as the models themselves, and have the capability of generating that AI bill of materials with all of that metadata that we talked about automatically for every one of those models to tie back your model to the code that generated it to the data that it was trained on. So we can go through a little bit of an exercise of how these bills of material will be generated and used for certain machine learning models. So you might start by training your own foundational model. Not every organization does this. It takes a lot of resources, but if you do train a foundational model, then you spend all the compute and data and everything like that to produce it, and then the first thing you want to do is create your AI bill of materials of all the inputs that went into that foundational model, and Radar can help you do that. So then once you create the foundational model, you're going to upload it to a model hub, maybe Hugging Face if you're open sourcing it, or some internal model hub if it's going to be more of a proprietary model. And then once you have that foundational model, either you or other people can go ahead and download the foundation model and fine-tune it so they can apply specific data to make the model better at a specific task, as opposed to the generalized foundational model being more of a general purpose tool. And so before they fine-tune it, the person using that foundation model wants to check the AI bomb, make sure that the attestations check out, make sure that the dependencies don't contain any vulnerabilities, and that the data set is all things that they are comfortable, extending. So then you fine tune the model with your own specific data, and then Radar can actually create a new immutable AI bill of materials for that fine-tuned model, so that you can actually not just rely on the old foundational model bill of materials, but you can have a new bill of materials that reflects the new fine-tuning data that went into this new iteration of the model and references the original foundation model bill of materials. And then lastly, once you're ready to deploy it to production, you can do one last check of this bill of materials, and again, make sure the attestations check out as a way of making sure no one's improperly modified the model, make sure all the data sets are exactly what you expect them to be and have no alterations or unexpected changes that could indicate poisoning, and make sure that all of your dependencies, once again, have not had any vulnerabilities that have been discovered before deploying it. So Sam can take it away with the key takeaways here.
So yeah, some key takeaways, the TLDR of the presentation. If you're looking at the kind of attack fronts that you need to be worried about, model serialization attacks is a big one. Model scanning is the answer for that, and our solution personally is Guardian. And on the more generalized front of the supply chain attacks that can come through the dependencies and data sets, AI bombs are the solution to that. And our tool to help with that is Radar.